algebra. Okay? Basically, it is going into finding all of your zeros and solving everything from there. So on the top it says identify the degree of each polynomial. Now some of these are not in they're not in standard form. Okay, but as far as the degree is concerned, we need to look at what is the highest degree. So if you have things that are combined, you're going to have to add those actual powers together. So what is our highest power? What's our highest power on one of the variables combined? Okay, so like 8ab, that is one term. Okay, 5b to the third, or negative 5b to the third, that is one term. Okay, and then a to the fourth, that is one term as well. So which term has the highest total powers? A to the fourth, right? So the only thing we've got to look at here is just that one single term, and it's just going to be a degree of 4. What about on 2? There's only one term, right? Okay, so there's only one term, so it's just going to be, it's x to the third, so the highest power is to the third. Now, what about on 3? What is our actual degree? Adam, don't multiply. 5, right? Okay, so since you have two terms, I'm going to take the 3 and the 2 and I need to add them, and my actual degree is going to be at 5. Okay, what about my degree for 4? 6? Okay, just right there. What about my degree for 5? 3? What about my degree for 6? 5, right? Okay, I have to combine, if you have multiple values or multiple exponents, combine those together. So now, over here to the right, what do you know about the graph? What are all things that you can tell me? Leading coefficient is negative. Is it an odd or an even power? Even power or degree. What do you think your degree is? 4? Why 4? Because it changes directions 4 times, right? Okay. Most likely 4. How many solutions can you see? 2. What are the solutions? So probably -3 and +2. So x is equal to -3 and x is equal to a +2. If it has a degree of 4, that means there's 4 solutions, right? 2 of them we can see. What are the other 2 solutions? Huh? Imaginary. Okay? We're going to have 2 imaginary solutions most likely. Okay? Or we are going to, because we don't have any other ones. Okay? So what's going to happen? You can see all of that just by looking at the picture. Okay? That is what a lot of fundamental theorem of algebra is going to be. Is going to be you looking at the picture, okay, or looking at the graph, okay, and kind of taking what we did yesterday and the possible solutions, or the possible real zeros or the possible rational zeros, whatever you want to call it, yesterday. Okay? There are going to be times that if you can get this to a quadratic, okay, you can either, what you're going to be getting really good at is synthetic division, 1. 2 is once you get it to a quadratic, and if you can't factor it or you don't have a 0, then you can always use a quadratic formula. Okay? All of these will be able to get you to a quadratic. Okay? You will be able to take all of these down from whatever power it starts. It doesn't matter if it's a 5th power, a 4th power, a 3rd power, whatever. You will be able to at least get it down to a quadratic. So if need be, you can use the quadratic formula to find your other zeros. Okay? So know that that is a possibility. So then, fundamental theorem of algebra really just says that if f of x is a polynomial of n degrees, where n is bigger than 0, if it's a positive value, okay, then the equation has at least one solution set of complex numbers. Okay? You may have complex numbers that do not have, like you may not have imaginary numbers. It may have every single value. Okay? So from here it says how many solutions does the below value have? So if it's x to the third plus 3x squared plus 16x plus 48, how many zeros do you have? Or how many solutions do you have? What's the highest power? 3. So how many solutions do you have? 3. What about on B? 4. Okay? Don't overcomplicate this. It's not that difficult. You look at the highest power. That's how many zeros you have. It didn't say that every single one you're going to be able to see, but it did say how many solutions or how many zeros you're going to have. Whatever your highest power is, that's how many solutions you will have. You may have some numbers like we've talked about before that have 2 answers. That's okay. You may have some, just like we talked about on the picture that you saw, that are going to be imaginary solutions. That's okay. So here it says if I have x to the 5th plus 3x minus 2x squared minus 2x squared minus 12x minus 8. What are my possible zeros from what we did yesterday? What did we do from yesterday? What did we have? What are the 2 values that we had to look at? The last one and the first one, right? So what are all of my factors of negative 8? 1, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Okay? So all the possible zeros that we have options, what are we going to divide all those by? 1. So are we going to add to that list? No. So the possible real zeros from what we did yesterday are right here. Okay, so you have to go back from what you learned yesterday. Amazing that we just built on what we did yesterday and now we're going to use it today. It's crazy that it works that way. But you've got to know what are your possible real zeros. Okay, so from here, this is when some sort of graphing utility comes into play. Okay, you only have 8, or if you don't have one, you need to go with basically pick and choose and see which ones you can try. Okay. The ones I would probably stay away from, I would definitely stay away from the largest value. Okay, I would probably not try 8 first. Okay, and use synthetic division. Now, if you have a graphing calculator and we have x to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8, I would go to your graphing calculator and plug it in and look at the picture. That's going to make things a lot easier because the picture is probably going to tell you where you can look, so you don't have to worry about trying, in this case, 8 different values. So if I have y equals, let's clear out the rational, x to the 5th plus x to the 3rd minus 2x squared minus 12x minus 8. Now, what am I missing? What don't I have in my equation? I don't have x to the 4th. That's going to come in handy whenever we do synthetic division. So whenever I graph this, if I have values, I had values of plus or minus 1, I had plus or minus 2, I had plus or minus 4, and plus or minus 8. Looking at a picture, which values do you think you would probably want to try?
1 and 8.
No. -1 and +2. Now, what do you notice that happens right here at that -1? Turns around. So how many times do I want to use -1? Twice. Okay? So I'm going to want to use +2 and -1, but use it twice. Okay? So this is where, using what we had as far as the possibilities, there's no need to try 4. There's no need to try -8. There's no need to try -2. Why? Because the line of the graph doesn't even come close to it. Common sense. Try what you think is there. So, -1 twice and 2 once. Then I can just go back right here to where I started and use synthetic division. So, if I'm going to use synthetic division from the values that I had, just like we talked about, which value am I missing? I don't have an x to the 4th, right? So I'm going to go 1, 0, 1, -2, -12, and -8. So we had our possibilities of plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Of those that I want to try, we talked about -1 twice and +2 once. It doesn't matter to me which one you try first. I don't care if you do the -1s first. I don't care if you go with the 2. It's completely up to you. Now, if we're going to use synthetic division, what has to happen, or what do we need to happen right down here? What does that value need to be? 0. Okay? If it's not, then we didn't pick the right numbers. Okay? If it's on a whole number, or on an integer rather, it's, for the most part, you're probably going to be in good shape. But you still want to make sure, so if I go -1, drop the 1, -1, -1, and -1 is +1, gives me +2, -1 and +2 gives me -2, then I have -4, gives me a +4, gives me a negative 8, and then a positive 8, and then we get a 0. Perfect. So, the negative 1 that I tried over here works. Now, what else do I have to do, though? I can keep going. What I would suggest, if you get a 0 right back here, okay, on the back end, just keep going with synthetic division. It's going to make everything a lot easier. So now, which number do you want to use? Do you want to use negative 1 or do you want to use positive 2? Huh? Positive 2, that's fine. So, drop the 1. 2 and 1 is 2. Straight down gives me positive 1 again. Gives me a positive 2. Gives me a positive 4. 2 times 4 gives me a positive 8. That gives me a positive 4. And then gives me a positive 8. What do you know? It zeroed out as well. So, the 2 works. What other value do I need to try now? The negative 1. Okay, I have to do it again. Since it happens twice, since it turned around there, I'm going to use that value again. And I'm just going to use synthetic division. So, negative 1, drop the 1. I'm at 1, negative 1, there's 0, gives me 0, gives me positive 4, and then gives me negative 4, and I have a 0. Perfect. I have 3 of the solutions that I have. I saw the negative 1 twice. I saw the positive 2. Now, at the very beginning, I told you that all of these, no matter how high of a power, it will always get you to what? A quadratic. Is there a way to solve a quadratic if here's my remainder, there's my constant, x and x squared? So I'm still left with x squared plus 0x, I don't have to write that, plus 4, and set it equal to 0. I still need to find 2 other solutions. I have 3 solutions. I need to find 2 more. How can I find the other 2 solutions with x squared plus 4 equal to 0? Now, this one's a little different. I can use quadratic formula, right? That's always there. But on one like this, what else can I do? Yeah, just subtract 4. Subtract 4 from both sides. Have x squared equals negative 4. Now what? Square root. So I'm left with x equal to, what's the square root of negative 4? Huh? Not 4? 2i. Okay? But both, I need one to be a positive and one to be a negative. Do I have 5 solutions? How many solutions do I have over here? 3. How many solutions do I have over here? 2. What's 3 plus 2? Amazing. Yesterday, whenever we dealt with the zeros, it's going to work the same way with the I values. Okay, so if you end up with imaginary. Remember, imaginary is just another way of saying it's a square root. Okay, it's just a square root. It's just 3 times the square root of negative 1. Okay, but 3i is going to be a little bit easier to deal with. So if I have, it says write a polynomial function of least degree, okay, that has rational coefficients and a leading coefficient of 1. 0 is 2, and then 3i. I'm going to do everything the same way, just like I did before, but instead, and if you need to, if you want to set it up as x equal to 2 and x equal to 3i, what other one do I need? X equal to what? If I have a positive 3i, what also do I have? A negative 3i. Same way, if they give you a negative I value, then you're going to have a positive I value as well. You should never have an odd number of I terms. So if you have a positive, you better have a negative. So just like we talked about earlier on 17, I'm going to take that 2 and I'm going to bring it over to the other side. I'm going to go x minus 2 equal to 0. I'm going to have x minus 3i equal to 0. And I'm going to have x plus 3i equal to 0. Now, what would be the two smart ones to multiply together first? The i's. Okay, so I'm going to take x minus 2 times x minus 3i times x plus 3i and multiply all of them together. It's no different than what you did yesterday or what you're going to continue to do today, for those of you that didn't. But it works the same way. Everything you do here is the same. It's just now it has an I instead of a square root. But what you do and how you set it up doesn't change.